Children, we will discuss about the variety of things we find around us today. You see a lot of interesting objects on the table here. If you go around the city or the town or the village, you see lots of things around. They all can be classified in different ways. Today, we follow a particular technique in classifying them. Science usually divides all objects around us into three groups: solids, liquids, and gases. You might have heard these words already. What are solids? Let me take the example of a stone. This is a solid. Here, material is packed well. Molecules, we call them. If we go on breaking this stone, we get tiny pieces. Crush them, beat them further, hit them, and ultimately you get very fine powder. Don't stop. With machines you go further. Ultimately you reach a stage where you get molecules. All objects are made of molecules. Now stone is a solid. Why is it a solid? If I even press it now, it doesn't get squeezed. It doesn't turn into a size smaller than this. It's hard. What's the word we use? It's hard. It is stony. It's rock-like. It is a rock, no doubt. It's rock-like, stony, very hard. You can't squeeze it further. It is solid. By putting force on it, you can't change its shape. It has a unique shape. Here, I have different kinds of stones of different colors. They are all solids. Here I have a bottle. This bottle, it's a solid. I can't press it and make it get transferred into a different shape. The shape is definite. All solids are definite shape. In this bottle, I have sand. Sand is also a solid. Sand has definite shape. You can't change the crystalline. They are crystal-like. You can't change their shape. So, the sand here in this bottle, the glass bottle, the plate here, the stones here, the pencil here, the eraser you use, or the bricks you use to construct your house, build the house, or the cycle, the bus, the aeroplane, all these are solids. Let me add one more example to it. Here in this bowl, I have ice pieces. Ice pieces. Very cold. I can't hold it for a long time. Ice pieces. They have definite shape. I cannot press it further. Ice cubes are also solids. We got enough examples. Now you can enlist many more examples once you go out. Now let us come to the second group. Liquids. You know what a liquid is. The moment I ask, you say water. Water is a liquid. In this glass I have water. Now see, you cannot squeeze water as you squeeze a solid. A liquid flows. See here, look here. It flows. I can transfer it from one vessel into another vessel. Liquids flow. Molecules here are not tightly packed. In the solid, molecules are tightly packed. In a liquid, molecules are not tightly packed. They slide over each other and water gets transferred into another vessel. In this vessel, I have phenyl. You know, you use phenyl to wash the toilet. It is a disinfectant. It kills bacteria. So, we use it to keep the toilet clean. Phenyl. Phenyl is a liquid. Phenyl is a liquid. If I open the lid and pour it, it starts getting transferred into another vessel. Molecules are not tightly packed in a liquid. In the solid, they are tightly packed. Here they are not tightly packed. We will come to the third group now. We said no in the beginning, we have three groups of objects. Here, you see, agarbattis are being burnt here. Agarbattis. What do you get from the agarbattis? The smoke. The molecules in smoke, they move freely in all directions. See? They spread in all possible directions. Here, molecules slide over each other. Particles of water slide over each other. Here, they don't slide. They move as they wish in all directions. See, they got spread out. They got mixed with the air around. I have another example here. You see, the stove is burning. I have covered the water in the vessel with a lid. Let me open the lid now. You see what happens. Yeah. What do you see here coming out? From the vessel, what do you see? It is steam. Water is boiling and steam is getting produced. Where does steam go? Steam is very light. It is lighter than air. It moves upwards. Moves upwards. If I blow, it will move in all directions then. And if I keep the lid like this for half a minute and then I remove, what do I find underneath the lid? On the under surface of the lid, what do I find? Let us see. You see here? What do you see? Water droplets. Water droplets, you see. The steam that was coming out of the vessel, it got collected on the under surface of the lid and it got converted into water, liquid water. See here. See the water droplets? Do you see the water droplets there? From where did we get the water droplets? We got it from the water in the vessel. That started boiling. Steam came up. Steam got collected on the under surface of the plate and water droplets got formed. Let us see now. See? Fine water droplets there. Water got converted into steam on boiling. That steam got collected here. You see them in the form of tiny droplets. Alright? So here molecules are tightly packed. Here they slide over each other. Water flows. Here water got transformed into steam and steam moves in all possible directions. Steam is a gas. Steam is a gas. Now we have dhoop here. You see? You use it for puja. When you worship the god, you burn dhoop, isn't it? See the smoke coming out? And it has fragrance. It has fragrance. Just like agarbatti smoke, this smoke too moves in all directions. It spreads freely in the air. It spreads into all directions. Okay, one more example here. We say air. Air surrounds us. There is air all around us. We breathe in air, isn't it? I take in air and I leave out. I take in and leave out. Now here we have filled the balloon with air. If I press, I feel there is some material inside. Something is pushing me backwards. As I push inwards, the air is pushing me outwards. If I just throw it up, I can see freely it flies in the air. So the balloon has air in it. The balloon has air in it. We cannot see air, but we can feel air. How can we feel? If I take this paper sheet and just blow it, you feel something strikes on your face. What is it? It is air. You make the air move about by moving the sheet of paper. And I feel the presence of air. Even as you breathe in, you feel the presence of air. When you breathe in, when you breathe out, see? You can make out. You can make out. Air as it comes out, it pushes the paper. Okay, now this book, what is it? A solid, liquid or gas? Book is a solid. It doesn't change its shape. It has a definite shape. Even if you keep it on the table and go out for 7 days and come back, the book will be there as it is. The same shape it will have. The cubical shape. Right? Now, you see water here in different vessels. I have 4 vessels here. All the 4 vessels, I got them filled with water. Here the shape of the water is different. What is the shape? You say, shape of the bottle. Water has the same shape as that of the bottle. Here water has the shape of the glass in which we have kept it. This is a narrow glass, a very narrow glass. Yet you find water that has taken the shape of that glass. Here we have a wide-mouthed bowl, and we have put water in that. There the water has taken the shape of that vessel. Water, in order to keep water, you need a container. This bottle, this glass, this narrow glass, this bowl or this bottle, all these are containers. To keep solids, you don't need a container. If you have bricks with you, you can keep one brick over the other. You can make a heap out of it. Or soil. If you get soil for your farm, the soil will be in a conical heap. Conical heap. It won't go anywhere. But liquids need a container. Isn't it? All liquids what you keep in your kitchen or in the house, you have containers for them. You keep the liquids in those containers. Again, gases too need containers. If I break this balloon, what will happen? All the air that it contains will just go out. I cannot hold it. I can't hold it like this. It needs a container. And the mouth too should be closed. Otherwise it will escape. So gases too need containers. Liquids too need containers. Okay, these are the differences between solids, liquids and gases. Once you see this video, you should start collecting names under each of these titles. What all gases? A football. A football will have air in it. and it is sealed. You put air inside and it's sealed. Air won't come out. Air will be under pressure there. That's why if you kick a football, the football will travel a long distance, 50 or 100 meters. It will move. So you keep air in a football under pressure. Now you see here, children, I have ice cubes. They have started melting. You see the water here. Ice has started melting. You know it. If you purchase ice candy, if you don't start eating it, what will happen? The ice candy will melt. Melt. What is the word I use? Ice melts into water. Your water. Much of the ice has already got melted. Your water. Ice melts into water. Water on boiling. Water on boiling, you will have steam. You will have steam. Now this steam, once it cools down, you will have, see, water. Water, steam, when it condenses or cools down, you will have water. Water on cooling down, you will have again ice. Ice melts into water. Water on boiling, you get steam. Steam on condensation, you get water again. Water on cooling, it gets frozen into ice. So it's the cycle here. Ice becomes water. Water turns into steam on boiling. Steam again gets back into the liquid form. The liquid will get solidified when it freezes. So ice melts into water. Water boils into steam. Steam cools into water. Water cools further into ice. Cools further into ice. Okay. You see how your mother cooks in the kitchen. What happens when she boils water? When she prepares coffee or tea, she has to boil water. You watch. You find out the transformation of water from one stage to the other. Read the lesson number 4 in your textbook. The questions pertaining to these objective questions I will discuss in the next video. Thank you.